Okay, we're good. Okay, I'll just give a few seconds to see if people are still logging on, and then we'll get started. Okay, welcome today to the latest installment of the JDI Roundtable on Manufacturing Competitiveness in New Brunswick. Today we're going to do a presentation of some data we've collected and discuss in particular the data with Martin Davis, CEO of Dunelm & Associates. Martin is critical for us because he devised a rubric or model of manufacturing maturity, technological maturity, based on different ideas about Industry 4.0 and how to think about driving productivity advance. So we were lucky enough to work with Martin earlier this year to develop the model, or Martin developed the model, which we then developed into a survey instrument. And then leveraging off some other work that we did from last year's roundtable, which was to develop a directory of manufacturers for the province. We've been administering the survey to learn more about just how far along our manufacturers may be towards an Industry 4.0 endpoint, and where do we see some opportunities for driving productivity advance and let's say strategic policy to help manufacturers up their game, gain international market share, grow our economy, and we all live happily ever after. So that's sort of the bigger run goals for today. I just noticed on our logo we have a yellow New Brunswick, which I'll say is a hopeful sign given the current turn to orange for the south of the province. We're hoping we can move back in the near future to less restrictions around COVID and think happier thoughts around how the economy is going to go forward. I want to point out, first of all, we had some objectives with the roundtable in case you've forgotten them. One was that we have the need to identify and enable research that focuses on competitiveness of our manufacturers in the province. We've been seeking stakeholder input to help define our research projects that we study. So we want to have research that's relevant to the broader community. And it's been important to share research to advance public understanding of factors that impact competitiveness in manufacturing competitiveness in New Brunswick. So when you see the presentation today, that's where a lot of our goals have been coming from. We were working with the community to identify the information we're going to provide as a need. And we hope that this helps advance our understanding of what we can do to grow the economy from our manufacturing engine. I also want to thank a number of people who contributed to this work in various ways. One is Lee Wong and Chin Ling Yan, who have been the research assistants doing all the dirty grunt work, putting the data together and putting graphs together, and they've been just terrific to work with. Ed McGinley was very helpful to us. He went out and interviewed a lot of the manufacturing leaders that we needed to learn more from. Ed spent a lot of the summer going door to door, talking to people, and was really invaluable for getting the data that we're going to see today. Sarah McRae, Rawia Mokhtar, Mara Mallory were all instrumental in designing the survey and putting it all together. So big thanks to them. Alec Milne of Framework Partners is a survey expert. He was the one who helped us make sure that we were asking the right questions and structuring it the right way. Pierre-Marcel Desjardins from Université de Moncton generously helped us by translating our survey from English to French as well, so we could offer it in both languages. Gaëtan Thomas, I want to acknowledge as well with the Conseil d'économique for helping with that and also making his community aware of our efforts. And finally, Bradley Shoebottom with Office of Institutional Analysis at UNB put together the survey online for us, and you can find the link to the survey if you wish to take it on the JDI Roundtable site. So what I want to point out is that Martin and I will be talking today, but there's actually been a large team behind the work you're going to see today, and it has been a lot of effort to put it together. So with that in mind, I want to just go into some basic facts that we want to remember why we care about manufacturing. First of all, manufacturing is a large wealth creating sector in New Brunswick. It accounts for 9% of total employment or 13% of non-government employment. So it's a large sector. So if you think about what are the largest things in our economy, the ones that stand out are usually public administration and health. Manufacturing is the only goods producing sector that comes close to those in terms of its importance. The difference between health and public administration and manufacturing is that manufacturing can create a lot of service jobs around it, whereas health and public administration, you're getting closer to the end point of the value chain and you're not going to generate as much of a multiplier effect from that spending as you would get from a dynamic manufacturing sector. Manufacturing is also the big prize for many economies. And with COVID and concerns about re-regionalizing supply chains, there's opportunities to grow your global market share if you're on your game. And we have a good manufacturing base to think about how do we get more value out of our producers, how do we get more manufacturers exporting, and how can we drive that with digitalization and technology? Are there solutions there? Among our manufacturing, 60% comes from food, wood and paper, and oil refining. And that's been fairly stable other than the decline of wood and paper manufacturing since 1997. That industry has rationalized considerably, but we've had a lot of stability and a return to growth, particularly in pulp and paper. Food manufacturing has been generally trending up since 2008, so that's positive. You can add in seafood as being particularly important within food. Breweries are another slight growth industry, not a large market share overall. But again, we have a very specialized manufacturing base, which also offers opportunities up for where we might be able to diversify the range of manufacturing activities that we have in the province. But it's important to remember we have a lot of strength in these industries, and we shouldn't be ashamed or afraid to look at gaining more by making them as competitive as possible. Last year, we learned this could be called the lighthouse model, which is taking your existing good manufacturers and making them great as a strategy. But then you can also go back and find your smaller guys and grow them. What does the geography of our industries look like? Well, this is the employment by wood product manufacturing. The height of the bar indicates how much employment is in the location. And what I want you to think about is just how concentrated and high the employment is in New Brunswick. So we've got some good wood product manufacturers. They're large, they've got a good scale. You compare that across to Maine, which tends to have more dispersed employment in wood product manufacturing, and Nova Scotia, which has a much smaller sector. And then you can see a giant spike in the Gaspé region where they have a very large company that's involved in wood product manufacturing there. Adding in pulp and paper, we see a different scene in Maine. They have much larger pulp and paper mills than we have in New Brunswick, but we still have a strong presence of that industry in our province, despite the losses in the northeast of the province after 2007. So again, it's a very impressive employment base that we could potentially grow from. Food manufacturing is interesting because it's spread throughout the region. And we have a high concentration of food manufacturing in New Brunswick, even compared to other provinces in the region. And so again, we need to interpret this as a strength of the province, that it's all over, it's got opportunities for rural, it's got opportunities for the cities. And again, we want to think about what it is that's leading to success and how we can do even better. When we get into these industries, which I brought up because these are the industries that were the focus of the 1970s diversification effort: chemical manufacturing, rubber products, fabricated metal product manufacturing, machinery, electrical equipment. These didn't show up in our large industries, but you'll see from this, the larger the dot, the larger the employment, they have a strong presence in the province as well. So we can't forget that we have these other opportunities, which are what we would call the less traditional manufacturing sectors, to continue to grow our game as well. And in many cases, these may be involved in supply chains for the region. And so if we think about competitive supply chain development, again, digitalization, technology are going to be big themes for getting the opportunities for more companies to participate in our anchor exporters' supply chains. One of the things we learn as well when we look at manufacturing in the region is that we have around 1,300, almost 1,400 manufacturers in New Brunswick. Most of them are small and micro, which means less than 20 employees. But the interesting part is that among the 200 or so medium and large manufacturers, they account for about 85% of the overall employment in the sector. So a smaller number of firms account for most of the employment. And this gets back to the idea of taking your good to great, is that your large companies in all 4 provinces and in the state of Maine, they're your big drivers of employment in the sector. So it's important to have scale. It's important to get those medium and large companies. And if we can grow those, we have an opportunity to get even larger. So again, one of the misconceptions is often we only think about small, But in fact, the big driver of the wealth creation at this point is the large manufacturers and the medium size that can grow even bigger. The challenges in the sector are we have stagnant productivity. So on the right-hand axis, you have dollars per hour, GDP per hour of output. That line has not grown since 2007, which is a problem because productivity growth is how we advance our standard of living. The black line is a measure from the left-hand scale, and it's called a unit labor cost. And it's basically the share of that value of output per hour in the red line that goes to labor compensation. So while we have stagnant labor productivity, we have rising payroll costs, which is eroding our competitiveness as measured by this unit labor cost. We have to start giving up more and more of our output towards paying for the inputs, which means we're not going to be competitive versus places with more productivity advance and stable or falling unit labor costs. So again, this is where people look to technology, investment, to think about how do you drive the economy forward. When we look at another measure of dynamism in the sector, this is the number of active employer businesses in manufacturing in the Atlantic provinces from Statistics Canada. In the region, what we see is that there's a declining number of manufacturers in each province, which is a sign that could be seen as a sign of decline, but we have to worry about where those losses and gains coming from, because turnover is also how you get some of the investment and some of the new technologies coming in. What we should be worried about is that our entry into manufacturing has slowed in New Brunswick. It's increased in Nova Scotia, which is something we should ask, why is Nova Scotia doing better on that dimension? But on the other side, the exit of the less competitive, potentially obsolete companies, it's declining as well, but we can't get the entrants to replace them. So we're not getting that turnover to get the new machinery and equipment coming into our manufacturing sector. It's looking like a decline dynamic, which is coming from that stagnant productivity, which is coming from a lack of competitiveness. So if we can figure out how to raise productivity, we have a chance to turn this around, and the way to turn it around is to get some entry, to get some investment, to get some of the new tech in, to get the digitalization, and see if we can drive the ability to compete in international markets better. So with that, I'd like to turn it over to Martin to explain his vision of what is Industry 4.0 and technological maturity, and then that will lead into, once Martin's done, a discussion of some of our survey results. Martin?
Thanks, Herb. Really good to be here. So what is Industry 4.0? Let's start there. So a lot of people think about Industry 4.0 in terms of robots, automation, technology, and things like that. And that's just one small piece of it. Yeah, you can see, there's a lot of different areas shown on the right-hand side here. But fundamentally, Industry 4.0 is about turning live data from your equipment into real-time information that allows you to make decisions and improve your processes, improve your productivity, and improve your manufacturing. And that could be manual or automated, in the kind of lower ends of the complexity. It could just be using data to make the right decisions. As you get more mature with it, it can be more automated, and it's actually using machine learning or artificial intelligence that's actually using that data to make the decisions. But fundamentally, it's about using data to make decisions to improve what you're doing. Okay, next slide, please. So, what is, sorry, go back one, please. Sorry, you skipped over one. Thanks. So Industry 4.0, why is it called that? So it's known as the fourth industrial revolution. We saw back in the 1780s, the whole mechanization, 1870s, got into mass production and the assembly line. The 1969, 1970s, automation, computers and electronics. And then today, you're into what's called cyber physical systems, which just simply means the coming together of the digital world and the physical world. How can we represent what's going on in the actual physical world using data? And how can we use that data to make better decisions and better drive what we're doing? Next slide, please. Okay, so, where do you start? Well, you start with the very manual kind of processes of collecting data, but driving through there gradually through getting more automated, through collecting data in a more automated form, connecting your machinery, putting that data into some form of database, analyzing that data, allows you to better understand it, better decide how to use that data. And as you gradually get more mature with it, you're using more advanced tools, building on that, allowing you to have good dashboards of what you're seeing, and driving all of that side of things. So you're gradually getting more automated. So you're almost getting to an autonomous state where tools that are using machine learning or artificial intelligence are then able to make better decisions. And we'll come to a little more of some examples of that in a second. Next slide, please. So if we look at some practical examples of Industry 4.0, I've thrown a few on a slide here, but let me just touch on a couple of key themes. So the first theme, and I've talked a bit about it already, is data. So how do you have sensors on all your machinery? How are you pulling data from those machines to give you, dashboards that allow you to understand what's going on? How do you know what's happening with your different machinery? Another example is maintenance. Basic condition-based maintenance that's using sensors to tell you how your machines are performing and what needs to be maintained, and then allowing you to then replace it. But that can be taken to next levels of predictive, and then even into predictive maintenance using artificial intelligence, and even beyond that into prescriptive maintenance, where these are aspects where the machinery and the sensors are telling you what needs to happen, and even generating a request for parts or whatever it might be, depending on the size of your operation. So these are all kind of aspects of Industry 4.0 that can allow us to drive forward and allow us to get a real handle on what's happening. And there's a lot of other aspects to that as well. You get into the advanced manufacturing side of things. So there we get into robots, autonomous vehicles, autonomous machinery, greater levels of automation within your factory, that whole aspect of advanced manufacturing. And that is a more advanced part of Industry 4.0, but it's all covered within that. And one just to mention just quickly is safety. People kind of think, well, why is safety part of Industry 4.0? But there is a lot of new tools out there to allow you to have active sensors on people and on machines to detect whether you might have a collision risk or a safety risk around that corner. If you're driving a large loader and you can't really see around the corner, you don't know somebody's just about to walk around there. But there's actually tools and technology out there now that allow you to detect that. So those are all part of that whole thing around connected sensors, ability to identify what's going on, understand location, understand everything from temperature to current to whatever else. It's all part of that kind of whole thing. But it starts with, what data do I have? How can I get data? And how do I use it to better make decisions in a manual, automated way? Next slide, please. Oh, actually, just one thing to mention before I kind of get on to this next piece. If you want to know more about this, I did a webinar for the Excellence in Manufacturing Consortium a few weeks back on the future of manufacturing. So that's out there. And we talk about all of these examples in a little more detail. And also very recently, with Cassie Simpson from Tech Impact, we did a podcast on Industry 4.0. So both of those are out there as well. Sorry, thanks, Herb. So if we talk about competitive advantage, so a lot of people say, well, Industry 4.0, well, isn't that the industrial Internet of Things, or industrial internet, or IoT, or whatever else? Aren't they the same thing? And I always argue that no, they're not. The Industry 4.0 is really a philosophy. It's a corporate strategy. It's about having that smart or digital factory, and don't be scared of the term digital factory. And just really getting information and using that data to make decisions is part of that. What's often referred to as operational intelligence, using techniques such as lean manufacturing or Six Sigma to better understand and improve how you're going about things. And that drives automation as well. It also gets you into trained and empowered digital workers. How do you actually get your people to be using that data to make the right decisions? And that, when combined with the industrial internet, with enabling technologies, such as the ability to connect all your machinery, to grab the data off that piece of equipment you have on the production line, use of industrial Internet of Things type devices, these wireless, fairly low cost sensors that can tell you what's going on. And that, coupled with existing operational data you have, allows you to drive your analytics and actually analyze what is going on and how you're better to utilize that information. And yeah, and that's supported by cloud computing, artificial intelligence, machine learning, etc. And that then drives you into competitive advantage, because if you can actually, yeah, put those approaches in place, get the data, use some of those newer technologies to help drive it, then you're going to increase your revenue profitability, increase your visibility, improve your OEE, and reduce your downtime. Because you'd be surprising how many companies don't really understand how often some of their machinery is sitting idle. And it's not until you really start analyzing and pulling the data that you understand, why is that machine down for so long? Why is it only being used 45% of the day, or those types of things? And when you get into that, that really starts to drive a difference. Okay, next slide, please. So back end of last year, I developed Industry 4.0 maturity model, as Herb referred to. And that was based around my experience over a number of years working in the manufacturing space. I'm an IT guy by trade, but I looked a lot of this as how does technology help drive manufacturing? And we looked at various aspects of what makes a successful company utilizing Industry 4.0 and other technologies like this. So it's based on real practical knowledge and things that we did in companies I've worked in and where I've been working with companies. So next slide, please. So the maturity model consists of 6 different categories, and each one of these has subpoints within it. So the first one, and very important, is leadership and people. Do you have the right talent, or can you hire the right talent, or can you bring in people from knowledgeable companies, such as a system integrator or something else that can help you? And then it gets into strategy. Do we have the right strategies to drive Industry 4.0? Do we actually have an Industry 4.0 strategy? And do we actually have that governance in place, the right senior leadership involved? And are we driving change management? Because it's not just about the leadership doing things, it's about how your people on the floor are actually utilizing this information. Key piece we talked about collecting, using, integrating, and adding context to your data. Absolutely fundamental to a lot of this piece. And then into the third bubble, you get into the manufacturing efficiency, where some of the things you'd expect to be within Industry 4.0, automation and robotics, and maintenance and safety. And then the fourth aspect is operational excellence. How do you drive OEE? And then it's the key components of availability or downtime, performance and quality. How are you using process improvement to actually improve the way you're doing things? Are you using digital modeling to actually look at a model of how you're doing things and help you to understand, if I change things in different ways, I can improve things? And then on the fifth one, supply chain, something people often forget about in terms of talking about Industry 4.0. How is your supply chain impacted? And that could both be upstream and downstream. So what's the flow of your raw materials? Are you actually tracking those raw materials from the moment they leave your supplier to when they get to you? And are you able to actually understand how long it's going to take to get to you, how that's going to impact your production schedule? And especially with COVID, where your supply chain might be suffering some disruption. And I think a lot of people track more their downstream supply chain when it's left us and it's going to the customer, and they're tracking it and making sure it's getting to the customer and things like that. So there's a lot of aspects of supply chain that can come into this as well. And then lastly, and by no means least, is technology. So what are the key aspects of technology? The ability to connect all your machinery, the Internet of Things, or use of augmented reality or virtual reality as well. And we can talk a little bit more about a couple of those as we go through the survey results in a second.
Thanks, Martin. So what we did is we took Martin's model and we developed it into a survey instrument where we had used Martin's categorizations from entry level all the way up to, I guess, Industry 4.0, or the right-hand limit, and 2 intermediate steps. And it was structured around specific descriptive questions that would help the respondent understand what each dimension was. And we started with having Ed McGinley go and interview 13 medium, and I think we had 1 or 2 large manufacturers in the province in our sample. We want to point out that when we present these results, we're likely looking at the best picture for the province. We're looking at likely the more advanced of the companies that are further along. We want to note that they're located throughout the province and they're located across different sectors. And because of confidentiality and things like that, we're going to present things in an aggregated way, not by specific company. We have developed an online survey as well. It's been available and still is, but we've had few takers so far. So we're hoping to still generate some interest in it so that we can add to this and get a better picture. But what we're sort of honing in on is that definitely among the medium-sized employers, we think we can find some real opportunities to learn more. What we did learn when we were putting our directory together is over 50% of manufacturers in the province that we could find some reference to did not have a website. And so we're not expecting them to be high up on the technological maturity. They typically, we would expect, be among the micro and the small. And when we've talked to other groups in Ontario, they've encountered the same thing, that what they've encouraged us to do as we validated our data was to stick with the companies where we could prove their existence through either an internet presence or even a Google map image of a Google satellite image of the factory, so that we could see that there's cars in the parking lot and things like that. So Lee and Ching Lin spent a lot of time doing that kind of manual data validation. So I think I'm very sympathetic to Martin's point that it starts with information and data and trying to figure out how to make decisions. So as we go through, I want to, I'll invite Martin to be sort of, I'll be the play-by-play guy and he'll be the color commentator if you watch sports, weighing in with the informed opinion. We'll all be the handsome talking head with the good voice.
I think as you rightfully pointed out there, Herb, it'd be great to get a lot more of the manufacturers to go through this survey, give us a lot better picture. But even with just the relatively small amount we have at the moment, there's some interesting points to note.
So our first picture, we've been calling these the spider diagrams, but we each spoke of, I'm gonna get, this is back to geometry. I'm gonna forget what it's called. We've got 6 spokes, so I'm gonna avoid embarrassing myself. And on each one, we've put one of the dimensions of Martin's model. 4 is the highest score you can have, 0 in the middle is the lowest. The red line is if just taking the sample mean score for the dimension of the model for the 13 companies. The mode is the most frequently appearing score, and the median is the one below which we have half the companies and above which we have half the companies. And they give a fairly similar picture. So we just want to point out that this is not sensitive to how we decide to depict the data. We are getting I feel we were getting a fairly clear picture about what was going on with these 13 companies. And again, with the caveat, this is an upward bias for the overall population of manufacturers. I believe this is as good as it gets for now. So it will tell us, even among the good, where would we focus our efforts? So Martin, when you look at this, what comes to mind? Is there a, as Ed McGinley would put it, is there a good, a bad, and an ugly here, or is it largely good or largely bad?
Well, just commenting on one of the things you just said, so given you think this is the 13 of the better ones, so what you're saying is it's all downhill from here. Given you've got ski slopes in the background anyway. So, yeah.
More opportunity, let's look at it that way.
So in terms of the good, the bad, and the ugly, obvious weakness in technology, and that's pretty obvious. But moderate scores in data and manufacturing efficiency and operational excellence. And I think one of the key things to note is that the higher end of those 3 on the right-hand side, data information, manufacturing efficiency, and operational excellence, the higher aspects of those will drive more use of technology. Yeah, you can do so much in terms of gathering data and of your manufacturing efficiency, operational excellence by manual means. But once you get past a certain point, you then need more technological help. So it's not necessarily about throwing technology at the problem. It's about increasing the maturity in those 3 aspects, and that will automatically drive greater use of technology.
So when we move now to the more detailed, you can see why we collapsed it to 6 spokes, but do we get any, do the 6 spokes kind of tell us what we need to know, or do we pick up some other things from this granularity where this is each of the questions we were asking the manufacturers about and grouping into those 6 spokes?
Well, I thought there was a couple of very interesting things that all of these ones thought they were very open to change. And I found that a little surprising. It may be the senior leadership is open to change, but I do wonder whether all of the people in those companies is open to change, because I think change management, driving change down through the organization is key to success. So I do wonder about that, and that'd be one I'd want to explore further. No real surprises. Augmented reality and virtual reality are very low. Yeah, that's probably what we'd expect. They're relatively new. I was a little surprised that operational excellence in the OEE and the downtime side was, that was lower than I would expect. Unless some of these factories are have got a ton of spare capacity, I'd have expected a lot of them to be looking at downtime quite a bit. So that was probably lower than I would expect as well.
So we've had a question come in about interpreting the efficiency score and just clarifying how we're measuring that. So the question is, what's the efficiency score related to? Is it some kind of objective global or national score, or is it we're just using categories that we've described and assigning a number or a score to it? Is that correct?
Yeah, so it basically for each set of questions, there's 4 kind of points on the maturity curve, from kind of basic through to advanced usage. And so it's not comparing against a particular national number or anything like this. It's actually, where does this manufacturer believe they are, given some of the statements and the questions we're asking them. And within the maturity model, it said, what does, within this particular area, it says, what does basic look like? What does advanced, etc. look like? And so it's allowing people to judge based on that. They're trying to take some of the subjectivity out there, but it's not based on anything nationally. No.
Well, I guess what it's based on is what you would call a transparent description of the state of technology or maturity. So, but again, it would be closer to what we would use with things like Likert scoring, where you're putting a number towards a category. Higher is better than lower.
Yep.
But that's a good question to address. Next, let's see if I can get my screen active again. We broke it down by the categories and questions. And this one is your first dimension, leadership and people. And again, what we're looking at here is the frequency counts of companies in each category. So gray is an intermediate score. That would be your 3. Advanced would be a 4 on that previous diagram. It's in green. And then red and yellow are basically giving us how many companies that we interviewed had entry and basic levels of scoring. And we put percentages on the bottom if you want to get a quicker read off of those. So when you look at this type of scoring or these kinds of outcomes, does anything stand out, or is this what you would expect to see?
I think really just the comments we already made. There's definitely the openness to change and diving into that in terms of, is that everybody in the company or just the senior levels? There's some good numbers there in terms of strategy, governance, and leadership, which is great to see. And obviously moving that more to the right will help. Getting the right talent, it is strong, but could be stronger still. People development, again, strong, could be stronger. So it's not, I think it's good, and these are for maybe more advanced manufacturers. So not unusual, and I'd be looking for some of those guys to be doing good things.
So it might be useful information as we broaden the survey, just to even get a better understanding of how many companies are even looking for this type of direction, the type of change, or are they just trying to keep going with what they've got because they understand it and it's predictable?
Yeah.
Now, with data and information, this is obviously an interesting one because there's so many different levels of use of information and data that it can almost be overwhelming. But when we look at this, is again anything surprising here, or is this what you would expect to see?
I think I was surprised this was lower than I expected, given these are maybe some of the more advanced players. The fundamental of running a good operation like this is understanding the data and what's going on. And you look at operational data usage, 4 in the basic, 6 in the intermediate. I would expect that to be higher. There's a lot of them collecting data, and if you look in the kind of the bottom piece there, But I think I just generally expect it to be higher, lower than I'd expected. And I think that just points to that whilst these are some of the better manufacturers, maybe the level of maturity in something like Industry 4.0 is not where we need it to be.
So I'm just going to jump back because I apologize for my amateurish use of Zoom. I'm tracking the questions and the slides, and there's two questions related to the previous slide on talent and leadership. So I'd like to go back if that's okay. One question is, so are the gaps in leadership talent around recruiting fresh new talent with up-to-date skills in Industry 4.0 techniques, or is it in having leadership committed to Industry 4.0? Or maybe a better question, given what we have in the information, is what's the relative importance of those two?
That's a great one. And I would say it's both. I think we need the right people involved. We need the right set of skills. Yeah, if you look at how you use data to drive better manufacturing, things like that, yeah, having a good process engineer who understands the use of data and how to drive things, either bringing someone in from outside as a member of staff, or bringing in an external company that specializes in that, or yeah, process improvement teams or other things like that. So the talent aspect is strong, but I would say there seems to be a greater understanding of Industry 4.0. Most companies have now heard of it, but what's surprising is the level of adoption is still lower, and this is globally, not just in the region. The level of adoption of Industry 4.0 is lower than you would expect, given the sizes of gains that are possible here. And that's just a focus on just using some of the basics, using data to drive improvements in what you're doing. So yeah, so I would say it's both talent and that having the strategy, having the drive, the leadership to actually go do it.
And I think this next question is more towards how we've been using the data on our end. So this one's my accountability, not yours, but it's about what weight is attributed to leadership, people, and culture when it comes to manufacturing technological maturity level. Is it 1/6 per the dimensions or something different? All we're really doing when we go to the 6 spokes is we're averaging the scores of the sub-dimensions to get an overall score. We've also played with things like just totaling up the numbers, but because there's different numbers of questions per spoke, it was easier to use something like the mean. And again, we haven't done anything scientific to figure out, is this the best possible way to represent the level of maturity? It was just sort of a simple one to do to give us some kind of thermometer of doing better, doing worse. We can't really read too much from my perspective into what's the dollar value difference between a 4 and a 3 in terms of bottom line, but we do believe a 4 would be considered better than a 3. And so that's why we've done some of this simple scoring. For the statistical purists out there, I know that won't be satisfying, but again, we're still working as we get the data to figure out the best way to represent the information that we're getting from it. And I have reached out to people who are experts at UNB on data visualization on other occasions. I may have to consult with them again. Another question.
I think the other thing to add is, yes, you could add some weighting to different categories and other things like that. This at the moment is just assuming equal weighting from all of the different questions and categories.
Yeah. Okay, manufacturing efficiency. Here we get into safety, maintenance, advanced automation, robotics, and automation. Anything standing out here for you, Martin?
Well, I thought that the most interesting thing on this one was the real bipolar nature of it, is the haves and the have-nots. And if you look at this here, it really is right the way down the line on every aspect. You've got a large number that don't and a large number that do, and they've gone from the kind of entry level to the intermediate. So that's kind of quite interesting. And it really shows that even amongst the most advanced manufacturers, only some of them are actually getting into some of these more advanced levels of manufacturing.
So would this represent one of the more expensive arms of technological maturity, or is there a way to distinguish on that front if I was, say, a policymaker trying to figure out if there's low-hanging fruit? So I'm afraid of investing in robots, but I don't mind you with your clipboard and stopwatch type thing. Or is this going to dimension where we shouldn't worry about the cost of getting the robots? They'll pay for themselves if we use them right.
Well, I think there is some of that, as you said. Yeah, if you've got the right strategy and you've got data to back up what you need, then getting into more advanced technologies, more advanced automation should pay for itself relatively quickly. I think you get into problems if you're buying equipment or buying things for the sake of buying it without actually defining why you might need it. Yeah, and okay, yeah, advanced automation and robotics can be expensive, but not necessarily. Yeah, there's some forms of automation that you can get into in your production that don't necessarily have to cost masses of money. And for example, maintenance. Yeah, maintenance, we're kind of a bit more spread across the map, but just using basic data to understand of how and when you do your maintenance. Yeah, because a lot of companies, the old way of doing it was purely a maintenance schedule. So every 3 weeks we replace this bearing. Whether that bearing is good, bad, or indifferent, yeah, you do it. You can then get into more advanced ways of doing it. Say, okay, we will use data related to that bearing, heat, vibration, whatever, and understand more when that vibration is starting to wear. And just by getting more advanced and using some basic data, you can then change how much your maintenance is costing. Yeah, because if you're replacing a bearing every couple of weeks or whatever that may have thousands of hours of use left, that's costing you money. Downtime, maintenance time, cost of the parts. If you're only replacing it more when you need to and you're actually taking note of the data, then you're saving yourself all of those aspects.
So we've got a great question, considering a number of our manufacturers in this survey aren't in the cities where you have good broadband and capacity for high-speed networking. How essential is enabling technology like good broadband access or to do the high-speed networking or get into a lot of these technologies?
There is a lot of manufacturing technology which can be local to just an individual plant. It doesn't need internet connectivity outside. And in fact, even with the cloud computing and everything else, particularly larger manufacturing plants will often have that data stored locally and initially processed locally. Because of latency with actually sending it up to the cloud, if you're trying to actually use that data for a real-time dashboard to make real-time decisions. So yeah, it doesn't necessarily need to have that internet connectivity. Okay, if you've got good internet connectivity, that may give you capability to use more advanced tools in the cloud to do some of that offline analysis and other things like that. But it's not the be all and end all.
So would that change if you're trying to get into someone's supply chain and they need information on, let's say, your own productivity or your own inventories and things like that? Or so you mentioned as a standalone, what happens when we have operations at multi-sites for some of these companies?
Well, quite often you do it as a distributed model. So no one has zero connectivity. You've got connectivity some form or other, but you can have it as a kind of hub and spoke type model where a particular manufacturing facility will gather data, may aggregate that data, and then send it to somewhere central. And okay, it, depending on the quality of your broadband or your internet connectivity, may depend how often you send that data, how frequently, how much data you send. But you can still do it in that kind of model. It doesn't all have to be sent and processed centrally.
So related to this, I think more picking on your sense or experience, do you get a sense that manufacturers are being held back due to the lack of connectivity and digital infrastructure, or is it a perception that it's necessary that would be holding them back?
Do I think it's holding them back? I think it would benefit them because then there is definitely more cloud services and things like that that would help them. Is it the be all and end all of them being able to improve and become more mature in Industry 4.0? No.
Okay. But as you know, the rural broadband, broader access to internet connectivity is a big policy issue right now around building back better from COVID. So it's an important focus that we think about what we need to wait for to get done with the big projects, and what we can do now is, in a sense, part of what we're thinking about, because again, earlier is better for competitiveness and quicker to market if you can do it. Operational excellence. Again, what we see here is we've got a bit more bold or red showing up versus gray. Anything standing out for you on this one?
Well, if you ignore digital modeling, and yeah, digital modeling is more of an advanced type technique. So yeah, there's probably going to be less of that. But if you ignore that one, you're seeing quite a bit of gray there. So a lot more in the intermediate side of things, and use of OEE and process improvement and techniques like that should be more common in a good manufacturer. So no, nothing massive there. Yeah, there's definitely some improvement that could be. Yeah, there's quite a bit of red and orange or yellow, whatever they call, color that is, there. So it could definitely move up. And operational excellence, use of OEE and those types of approaches, been around in manufacturing for many years. So there's definitely some maturity that could be adopted there, even with or without any form of technology.
Now, the interesting part is we've got a bit of lag between questions and the content we're on, so I'm going to jump you back again just to keep you off your game. Questions come in. I'm going to leave people. I've been not naming people like my friend Matt George likes to do to sort of make everyone feel personally engaged, just in case the questions are a little more pointed. This one could be. So it's a great question, but I'm going to leave the questioner anonymous just in case. But if the bulk of our companies, and these are the 13 good ones, don't even understand lean and predictive maintenance systems that are far from new, do we have any hope at all where Industry 4.0 is concerned?
I think this is more of a statement than a question, actually.
Well, again, this is one of the challenges we've encountered through the roundtable is sort of a perception that we can drive this at the, let's call it the advanced end with investments there, but then we had a message repeatedly at the roundtable last year from lean and productivity experts to stop talking about the digital, stop talking about the robots, go back and do lean, go back and do the basics.
Yeah.
And again, this is maybe the tension where we know where we need to get to, but really the question, I don't think that where we're at is a negative. It's a question of where do we start and what are the steps to get the ball rolling. And the reality is if you have companies that don't have a lot of what you call surplus time to do the strategy, that don't have a lot of surplus in the budget to make the investments, you could wind up with margins where you cut corners or you don't put the time into doing those basic things because you're trying to make the most of when times are good, and when times are lean, you can't afford it. So I think it's a great question. It's one that keeps coming up again and again. Like, does this make sense to go after the automation, the AI, and all the fancy stuff? Or is this really, we got to learn to walk before we run? And it might even be a cheaper way to get started, but just not as exciting or runs the risk that it would be interpreted as negative by the tax-paying public.
And I think that you've hit the nail on the head there, Herb, which is, and we'll come to it on the kind of last slide as well, that throwing technology at a problem for the sake of throwing technology at the problem doesn't usually end up well. Yeah, it's got to have some of the basics in place and things first. And starting with some of those basic capabilities, even if it means a clipboard and a stopwatch, but actually getting some basic information about what's going on and building on that and becoming more mature as you develop. And then getting into like lean, good practices around lean. Moving from calendar-based maintenance into condition-based and predictive type maintenance. All of those things, as was commented, are not new. Yet there's so many of those basics that are not being done that if you actually start people on the right path, they can actually see some of those benefits. And I'm not sure if you've ever seen the cartoon of the cavemen pushing the cart with square wheels. And another one comes along with the round wheel and said, "Look what I've got for you." And they said, "Sorry, we're too busy." I think we suffer from that kind of mentality, that there's too many of the smaller to medium manufacturers particularly that are so busy trying to survive that they don't have the time to actually improve their capability, improve their productivity, and improve their profitability by doing that. So it's so much hand to mouth. And so enabling and helping them to actually use some of the basics that they can do that relatively low cost, then they can start getting more mature and getting into other things. And that will help them and continue to help them. And I think some of that, in my mind, would drive things forward a lot more.
And just before I go on to the next slide, comment has come in, or it's essentially, I'm going to call it a comment because it's a question I don't have the answer to. And it's a good one. How widespread is the engineering talent in New Brunswick in the smaller firms to put the hardware and software in place? Like, this may be just a case where we need a thicker consulting network that smaller firms can access, or it may mean we need more talent being produced from the college system and the university system that can be that hands-on employee that knows how to do this. So it goes back to the search for talent, I guess. And again, in most provinces, I think we have a training system based on industry 3.0 at best. So have we made the transition in terms of creating the conditions to get to 4.0? That would be something we should investigate through a roundtable type study, just seeing how well aligned we are.
Yeah,
But again,
no,
we would need to
yeah.
know from someone like yourself, what's the talent that we're actually trying to produce?
Yeah, and I think that there's all sorts of things there, and it's not just around engineering talent, and not necessarily about hiring people. Yeah, we have a number of small system integrators, small to medium-sized system integrators that can help with some of those things. We have specialists in lean and specialists in different forms of maintenance and other aspects like that. So sometimes it's actually encouraging those companies to actually contact the right people, getting help to actually use some of their expertise. But they've got to have that kind of drive and that strategy that they want to do some of that, and they're going to put the governance behind it. They're going to drive it. They're going to get their people on board with it, et cetera, et cetera. It's all of those aspects. Yeah, that the reason there is 6 spokes in that model, and it starts with the leadership and people, is very much because it starts there, and it kind of it all builds on itself.
Wow, this is getting tough for me. I keep coming up with problems and you keep firing back with solutions. So I'm going to be out of business. So let's go to the next one with supply chain. Again, here, if anything stand out that you think is worth commenting on, or is it what you would expect?
Given some of the supply chain side of things, particularly just in time, is a more advanced techniques you see in like the big auto manufacturers and those types of things. I was pleased to see that there was actually a bit more maturity than maybe I would have expected, particularly on the just-in-time delivery raw materials. I think with COVID, this has kind of thrown some of this up in the air a little bit, where the supply chain and the delivery of parts and materials and things has become more disrupted. Yeah, the ability to actually understand what's going on in your supply chain, I think, is becoming even more critical. But apart from that, no.
So another interesting statement has come in, not a question, but I may try to ask you as a bit of a question to see if this is happening anywhere. The observation is made that countries are trying to improve the health of the population, providing vaccines at no cost. Perhaps we need to provide manufacturers with zero cost knowledge and implementation support for basics like lean. So in a sense, a universal lean program, tax funded. Are there any examples maybe in Europe where they do something like that, where there's a bit more of a collective approach to the industry coming from the public sector?
I'm really not sure. David, thank you for the question, and good to know that you're on, by the way. It's definitely something that would help. I think there is, we're all too ready to throw money at the sexy technology and artificial intelligence, things like that. But I think there's, especially with the small and medium manufacturers, there's some help with the more the basic level of things, and helping them mature would actually do a lot of good.
And someone has pointed out that ACOA does fund lean programs. And so again, this may be a case of how well the uptake is, or knowledge of what's available, or are there barriers to accessing it? But I do want to be fair to ACOA. ACOA has been a large investor in lean and productivity. And so again, the challenge is always you can make programs available, and if people don't use them, we have to figure out why that's the case. And certainly we've seen with vaccinations, it's less than universal uptake. So again, it's not always the cost of it. It may be the time, and as Martin's pointed out, the orientation and structure and strategy that would make sense to use it. Let's see, I think we're getting down to the last dimension, technology. Now we're into the red.
Yeah, so no surprises, virtual reality is barely being used. Yeah, no surprise at all. I think the The one here which has a massive opportunity is augmented reality, and especially given the remote locations we have around Atlantic Canada, and given restrictions on travel with COVID, augmented reality, and let me give you a real life example. You've got a maintenance guy who's trying to fix a problem with one of your pieces of machinery, has basic knowledge, doesn't have the skills to actually fix it. And let's assuming that he's got the appropriate parts he needs, has been shipped in or whatever else. But the ability to use augmented reality, so a remote engineer, an expert, wherever they are in the world, is looking at exactly what they are looking at and is able to actually feed them instructions through an augmented reality headset, glasses or whatever, and help them to actually do the repair from wherever they are. And you think of the possibilities of that, and you think of, given COVID, given we've got manufacturing in dispersed locations, rural locations or whatever around the province or the region, the possibilities of that is really, really strong. And and that's not science fiction. It's not massively expensive. It exists now, and it's the adoption of it is increasing rapidly. So there's a definite possibility with some of that.
So when we think about the challenges with the labor shortages and skills shortages, that's a pretty intriguing technological solution. The only thing I hope is it doesn't go towards doing do-it-at-home surgeries when we can't get doctors or things like that.
Well, there's actually a company down in Boston called PTC, and they have an app called Chalk, as you expect, chalk on a whiteboard, that you can actually, you have two people install that on your phones. And it allows you to, let's say, you're broken down the side of the road and you've got a friend who's a mechanic or something else. You can actually point your phone at the engine and they can actually be looking at the same thing, and they can actually draw on their screen and draw around a piece they want you to check or look at or something else. And even as you move your phone and your phone moves, the circle stays around the piece they've actually circled. So it moves as you move. So it actually detects, and that's just a form of augmented reality, a very simple form. It's a free app that's out there, but PTC is one of these customers really driving advanced augmented reality, point and click. And there's actually, I'm trying to remember the name of the company, but there's a really good company up in Fredericton area that has been doing a lot in the augmented reality space, and the name slipped my mind.
I think we're getting some questioners writing in. It's Cognitive Spark, I think.
Cognitive Spark, that's the one I was trying to think of. And yes.
Again, we should point out this is an example of where the industrial needs could spill over into opportunities for startups, for tech companies to enter into the space in the region. So again, it's not just manufacturing, it creates a reason to bring in some of these other types of companies. We had a question for clarification as well. Earlier in the presentation, autonomous level included AI and machine learning. Is it tracked in the maturity model? So
yes, AI machine learning. I think we've maybe just missed it off. It is there. Yes.
Yes, it's definitely in the model.
Yes.
I probably just skipped over where it was or left a label off, but it's good to clarify that it is there. So as we head into the final few minutes, in 3 minutes or less, Martin, can you explain how to fix all of manufacturing?
So I just say no and we'll carry on.
I think the big questions are, as we've been covering them as we've been going through, it's just, is there advice on where manufacturers should start? From a policy perspective, should we have government thinking about targeting medium and large firms with the lighthouse model to push them to being large and globally competitive and world class? Or is the game here we could do better with a broader swath of a large number of smaller companies and moving them into the medium range and picking up the incremental gains as we go along? And again, we want to think about how we can get the broader supports and the growth. And then a question that always comes up, people pose to me when I bring this up is, and I don't know the answer, is how big are the potential productivity improvements that we could get from this and output growth? So I think you could speak to it from a company perspective. Maybe some examples you've seen, a company went up by 40% on their output. But if you have any thoughts, I'll let you finish with the slide you put together that really addresses this, which is your virtuous circle. So your final
Yes.
advice for the
Yeah, so
audience?
just to kind of finish off on this, so a lot of these pieces are interconnected, and this kind of will help hopefully answer some of those questions. You can draw it as a virtuous circle, like this, self-reinforcing. So you start with data and information. That helps you make better decisions. Even just start with stop watching a clipboard and then start looking at what is going on. How often is your machine utilized? How often is it down for maintenance, et cetera, whatever it might be. That then helps drive you. That data is key to helping drive operational excellence. And if you're getting strong on operational excellence, that helps increase your profitability. If you've got better profitability, you can invest in more advanced manufacturing and improve your efficiency further, and technology, and that gets you kind of into that whole aspects of automation and robotics and connected systems and IoT, et cetera. And by adding those tools in, that generates even more information, and it's self-reinforcing. So it's that whole thing around starting simple and building on it. And then the core of it still has to be, though, have you actually got a strategy of what you're trying to do? Are you actually proving things out and then building on that? You appropriately governing what you're doing, and change management so that the people realize why you're doing it. They're having their input and they're helping you to actually drive it. So all of those aspects, and that's why the model has the different dimensions and everything else, and trying to actually interconnect the dots. So starting simple, building on it. Does that help, Herb?
Yeah, I think it does help for the lay audience like me a lot. And we're the ones that I think have to be convinced quite often when an ACOA or an ONB or another body or RPC is trying to get some support for doing this kind of productivity advance, that this is going to be worth it for the economy and society. And so I find this extremely helpful, just in thinking about, it's not just about buying the robots. It's not just about the tech. It's really about, I guess, business leadership and a culture of using information in a way that is strategic and effective. And so I think we've hit the end of our hour, but Martin, I'd like to thank you for a great conversation today and helping us with the model of technological maturity and giving us your thoughts on the initial observations we've seen. And for those of you who have hung in for the couple minutes of injury time going into over, to use the soccer analogy, we have our final roundtable event for the fall semester. It'll be December 10th at 2 p.m. And we're going to have a panel, Kathy Simpson, Tech Impact, Adrian O'Prey, the Business Council, Sherry Somerville from the Atlantic Chamber. And they're going to be talking about how they see manufacturing competitiveness as an opportunity for invigorating the business sector and growing the economy, and how their different organizations see the opportunities. So again, thanks everyone for tuning in today. I apologize if I didn't get to all the questions. We had some great ones, and enjoy your weekend. Thanks very much, Martin.
Thanks, everybody. And thanks for all the questions.